Hello and welcome to Chemistry Session 1. This is the first of 3 sessions, and our team today, I am Dr. H, Marcy is my moderator, and Brian, without whom none of this would be possible, is actually making sure that you can see the feed. Now, Marcy, as moderator, will be monitoring your chat. I can't see them, but Marcy can. And if you have questions for me, put them there, and then Marcy will forward them to me, and I will try to answer them. So there will be a little bit of a lag, but I will certainly try to get through all the questions that we have. So on the agenda today, certainly I want to talk a little bit about the Chemistry 2021 testing, preparing for AP Chem, and how we at Princeton Review can help you out. So last year, basically, a lot of people took the test, using their own devices. This time, they are going back to what we call the old or traditional version of the test. But of course, there are some changes because they will not be having the test only on one day like they did before. We actually have 3 days for having the test. So on May 7th, it's going to be the paper-only test, and you can only take it in your school. The second administration will be on May 25th, and that is also a paper-only, and you can only take it in your school. I think this should say 8 a.m. local. I believe that's what they should say. Okay, and then on June 10th is when you have the digital version. And depending on what decision your school makes, you can either take it at school or at home. And that is a decision that your school makes. To make sure that everyone is taking it at the same time, they have set the time to 12 p.m. Eastern Daylight Time. So some of you might be taking it earlier, some of you might be taking it later, but this is what they have actually come up with for the chemistry. Okay, as far as the test itself goes, section 1 of the test, which is actually half the test, it's 90 minutes, 60 multiple choice questions. Now I said single and grouped because sometimes what happens is they may have a set of 2 questions, rarely 3 questions, that will be part of the same description. So that's the multiple choice, and that's what we will focus on today. Part 2, this is on the traditional test, the paper and pencil test. They will have 3 what they call long response questions, which is 33% of your grade. And they will have 4 short response questions, which will be 17% of your grade. In session 2, we'll be looking at the short response questions, and in session 3, we'll be looking at the long response questions. Okay, the units that are covered. These are the units as per College Board that will be covered. And this is the relative weighting of the units. Now, as you see, the heavier weighted units are intermolecular forces and properties. That's a pretty important unit for chemists. And acids and bases, which is another very important unit for chemists as well. Thermodynamics actually gets a double hit with thermodynamics here and then applications of thermodynamics. So it does show up twice, although you can, depending on your school, your curricula, you may be covering Unit 6 and Unit 9 together. And when you'd be covering it, of course, depends on your school. But thermo does get a double hit because it is so important, especially well, in several fields where thermodynamics do dictate the rates of the reactions and reactions, and there are quite a few of those. Okay, so preparing for the AP chemistry. what do we need to do? So what I have here now, you will notice that I did not have what is different between the paper and pencil test and the the digital test. I will talk about those differences tomorrow in our session tomorrow, not today, because there's a fair bit that I would like to cover today as far as multiple choice questions go. So my intent here is not to give you technique and not to give you content for chemistry. Your school does that, and there are many resources available that will give you content. There are fewer resources that talk about how to actually approach multiple choice questions, and that's what I want to do here. So as you can see, my question here is pretty generic. A chemist is comparing, and then we don't know what that is. If this, then which of the following best describes the relationship between Ka or pKa and presumably R? Fairly generic. So what I'm going to do here is, the question is so difficult, didn't even understand it. So I'm going to go through and write down what these relationships are between Ka, to simplify my work, between Ka, although I have pKa here, and R. So the first one says, as Ka decreases, R decreases. The second one says, as Ka increases, R decreases. The next one says, as pKa decreases. So as pKa decreases, it means Ka increases, R increases. The one after that says, as pKa increases, that means Ka decreases, R decreases. At this point, I know what the answer is, and I'm sure you do too. And the answer is B. So why is it B? It's B because these are going in the same direction. This relationship is going in the opposite direction. This relationship is going in the same direction. And this relationship is also going in the same direction. So essentially what I've done is I have used a technique called Sesame Street. Sesame Street basically says that you can't have several right answers. You can only have one right answer. So those answers that are the same or functionally the same as each other, well, those answers can't be the right answers. Okay, so the technique used here is really, if I can get my text box, there we go. Can't have more than one right answer. So what this means is that if there are two answers that are functionally the same, we can eliminate both of them. Okay, let's take a look at the next one. Here's the next one. Now realize on this section of the test, you can't use your calculator. On the other section of the test, where you have the short answers and the long answers, you can use your calculator, and it is encouraged that you use your calculator. So, so yeah, it'd be good to use your calculator for those. Here, what we have, it says if the conversion of 30 grams of uranium metal to uranium hexafluoride were attempted by this kind of treatment, how much uranium hexafluoride would be formed following this reaction? And fortunately, they balanced this reaction for us. Now, normally what we would do is we would take this, we would convert it to moles, we would convert this to moles, and try to work this. And that is like, So let's step back a little bit and take a look at this question. I have 30 grams of uranium and 10 grams of fluorine, and those are the only two things that are going into my reactant side. The only thing I'm getting out is uranium hexafluoride, which means the most uranium hexafluoride I can get if all of this combines is 40 grams. And if that is the case, then I hope you see that these two answer choices don't make sense. Okay, so I could eliminate these two answer choices just based on common sense. Now we got these two answer choices. Well, we could use common sense again to say, well, if I have to have 40 grams of uranium hexafluoride produced, then these two have to be stoichiometrically correct. I need to have 1 mole to 3 moles ratio to get this. So let's take a look at this. They did us a favor and told us what the atomic weight is. So I know I need 235 grams of uranium hexafluoride, and they have to convert with 3 moles of F2. Now, what's the molecular weight? Molecular weight of 3 moles of F2. Well, this is the same as 6 times molecular weight of fluorine atom. And if you look in the periodic table, fluorine atom is 19 grams. So what I'm going to do is I'm going to say this is 6 times 19. 6 times 19 is, of course, 6 times 20 minus 1, which is 19. And now my math becomes a lot easier. This is 120 minus 6, which is 114 grams. So 3 grams of fluorine is actually 3 grams of fluorine gas is 114 grams. I hope what you notice is that this is an approximately a 2-to-1 ratio, while what they've given us is an approximately a 3-to-1 ratio. So we will not get 40 grams, we will get something less than 40 grams. Now, while I don't know what that something less than 40 grams is, the answer choices have told me what that something less than 40 grams is. So I have to trust the answer choices and take their word that it is indeed 29 grams. Notice that what I had to do here is I had to say, okay, go ahead and use what they give me to then go ahead and say, fine, they are giving me, I've eliminated the other answer choices, and so whatever remains must be the credited answer. So that would be using the same tactic that Sir Arthur Conan Doyle did, the guy who wrote The Mysteries of Sherlock Holmes, basically using process of elimination. So let's take a look at the next problem. Marcy, any questions yet? Any comments I need to know? Is this what they're looking for? Is this not what they're looking for? Not yet? Okay. Okay, so here's another question. It says, which of the following will be paramagnetic? Now, what is the definition of paramagnetic? And I'm sure you know these. Paramagnetic means at least one unpaired electron. Now, so essentially the way they want me to solve this problem is they want me to figure out the electron configurations of all of these. Well, could I find a smarter way? Well, maybe. The smarter way is those that have similar electron configurations I can eliminate. And there are actually two answer choices here, which I can eliminate because they do have similar electron configs. And that's these two. I said similar, not the same. So these two have noble gas electron config. Neon is a noble gas. Br minus now has a full octet and has a noble gas configuration. So I can eliminate them both. Now, the other thing I need to do is if paramagnetic is at least one unpaired electron, then if I have an odd number of electrons, I know it is paramagnetic. So odd number of electrons means paramagnetic. If I have an even number of electrons, then I actually don't know because they may be paired. They may be some unpaired ones. I could have two unpaired electrons, for instance. So so even though it may be an even number of electrons, I don't know. So now what I'm going to do is use this test first because it is the easier test to work with. So Sn plus 2 would have how many electrons? This is where I look in the periodic table. I see Sn is element number 50. So Sn plus 2 will have 48 electrons. Cr plus 3, Cr is 24. And if I remove 3, I will be at 21 electrons. And now I see that this is an odd number. This is an even number. If they were both even numbers, then the next thing I would do is then I would solve the problem. Okay, but what you could do is you could say, well, this may not work. What if both of them are even? Okay, if both of them are even, yes, I'll find the electron configuration. Does that mean I will find the electron configuration right away? No. What I will do is I will first try to eliminate. It doesn't take that long to eliminate answer choices. And then I will actually look for electron configurations that will help. So what I was trying to do here is I was trying to use process of elimination first. Okay, so that's what I was trying to use process of elimination first, not last, not when I can't answer the question, but before I even start doing the heavy lifting of writing out electron configurations and things like that. Okay, here's another one. Isotones are nucleides with the same number of neutrons per atom. Which of the following atomic species is an isotone of Zn64, zinc 64? Now, before we even start, there are some areas that we can actually go ahead and eliminate. One of those is right here. I can eliminate zinc 66 because this is an isotope. And if it's an isotope, and if you know the definition of isotope, the same number of protons but different neutrons, then you know it can't be an isotone, right? And I can eliminate Se. And the reason I can eliminate that is because the numbers are just way too big. So you can just estimate and know that this won't work. Zinc, by the way, if you're looking at it, is element number 30. So you're looking at essentially 34 neutrons here. Nickel. Notice that the mass of nickel is the same as the mass of zinc, 64. We know that the number of protons for nickel are different than the number of protons for zinc. So if their mass number is the same, but their number of protons are different, then the number of neutrons have to be different. And if that is the case, then the answer has to be copper 63. Okay, pretty cool. Okay, I don't see any feedback from Marcy, so I assume it is. So what you want to do here is use process of elimination. Okay. And work in small chunks. So that's what I used here to actually get to the answer. And as you see, as I try this, if you were actually trying to calculate out the number of neutrons in each one of these cases, it would actually take some time. Here, I can actually get through the same problem in a third of the time, half the time at the high end, sometimes a quarter of the time. So what that does is that leaves me the time that I need. Awesome, nice. Nice, thank you for the comment, Shirti. I can actually use the rest of the time to do some of the harder problems that require the additional time. We have 60 questions to do in 90 minutes, which works out to be a minute 30 per question on average. Remember, that is the average time per question. Some questions we can do in under a minute. There are other questions that will push to 2 minutes, maybe 2 minutes 15 to be able to get the answer because the calculations demand that. So the way we actually get through all the questions is by speeding up through the questions we can speed up. So we have the additional time to slow down and take our time and get those questions right where we need to slow down. It doesn't mean that we speed up on the fast questions and kill our accuracy. Okay, so number 5, electron configuration of Fe plus 2 is identical to which one of the following? They just want me to know these electron configs, don't they? Here is where knowledge, a little bit of knowledge, can go a long way. And if you know about ionization, so that the piece of knowledge that I will use is that you actually ionize the s electrons before ionizing the d electrons. So because this is an Fe plus 2, and because I know that Fe actually is in the 4s shell. Well, part of its electrons, just Fe would be in the 4s shell. The others would be in the 3d. You know that Fe plus 2 will have no 4s electrons. So Fe plus 2 does not have 4s electrons. Now, why is that important? The reason why that is important is because when you are filling, you fill the s electrons before you fill the d electrons. And when you are removing electrons, when you're ionizing a transition metal, you actually ionize the s electrons before the d electrons, which means, yeah, that's a good question. I'm going to get to your question, Shirti, in a minute here. Let me get through this problem and then I'll answer your question. So I would actually eliminate these two answer choices. The reason why I would eliminate these two answer choices is because both of these have 4 s electrons. Now, when you look at these two, what you realize is that Ru is actually in the wrong row. So the only one that would have the same electron configuration of Fe plus 2 as Fe plus 2 would be cobalt, Co plus 3. Okay, so the answer to your question, Shruti, is that the test is testing how you do the problems. They don't know or care for the multiple choice, how you arrive at the answer, but that's what they are looking at. So you need to review the content so you know the content. But at the end of the day, what you are being tested on are the questions, the multiple choice questions. That there is a technique for multiple choice questions. You need to know the technique. So therefore, you need to practice the technique as well. Okay, so if you know most of your content, then I would actually go ahead and do practice problems. If you need to learn the content, then let your practice problems tell you what content to review and go review those content. I mean, here we are, we're so close to the test that the content review that you want to do, assuming you have it in the earlier part of May, uh, the content that you have to work on, I mean, you just don't have time. So you need to be able to do the practice problems as well. And I assume in your school, you'd have probably already started doing practice work as well for the AP exam. So that's why I think something like this, which tells you how to tackle the problems, is timely. Okay, hopefully that helped you. But thank you for the question. Okay, let's take a look at this. It says, which one of the following ions or atoms would be a suitable substitute for cobalt plus 2, which is used for its paramagnetic characteristics? Now, essentially what they're asking here is, remember we had all of these electron config questions. Essentially what they're asking here is, which choice has the same or closest electron config to CO plus 2? That's what it's asking. So there's a little bit of interpretation that goes on here. Okay. So if we're looking at that, let's take a look at CO plus 2. So what can I eliminate? I'm going to use the same thing as well, right? So we're going to work in small chunks. We know how to do that. So we're going to work. And we're going to work in small chunks to eliminate answer choices. That's what we're going to do. The answer choices that we can eliminate, because CO plus 2 is actually a plus 2, is we can eliminate Mn. We can eliminate, because this one has, so CO plus 2 does not have any s electrons. We can eliminate this one because it has s electrons. We can eliminate this one because it is in the wrong row. Now we are left with two answer choices, nickel +3 and copper plus. So what I'm going to do here is I'm only going to write the electron configuration for one, because they already tell me that CO+2 has paramagnetic characteristics. Okay, if any of these answer choices don't have paramagnetic characteristics, I will eliminate them. So Cu+2, let's start there. We don't have a choice. Cu+2, its electron configuration is what? Well, Cu+2's electron configuration is argon, 3d10, and I know that this is not paramagnetic because all the electrons are paired. Not Cu+2, Cu plus. All the electrons are paired. So if all the electrons are paired, then I know this can't be the answer. That leaves me with only one. Okay. Now, what would have happened if I would have started with nickel +3? Well, if I'd have started with nickel +3, what would I get? Well, I would have written down the electron configuration for nickel +3. Nickel +3 has electron configuration of argon, 3d7. Okay, that is its electron configuration. Now, it turns out that cobalt +2 has its electron configuration as argon 3d7 as well. So what I had needed to have done at that point in time is actually looked at the electron configuration for cobalt, realized that they are the same, and then gone with this answer. I would not have done the electron configuration for copper because these are identical electron configurations. I couldn't ask for a better substitute. Okay, now if these were not, if let's say if this was 3d9 instead, then I'd look at the next answer choice to see if there's something that is going to give me something that is more similar to cobalt 3d7. But typically they will not do that to you. I mean, if they're asking for something that is similar, um, essentially they're looking for electron configurations that are the same. Okay, let's take a look at this question here. H2SO4 has a high Ka for its first deprotonation. However, the second deprotonation, it has an associated Ka of 10 to the minus 2. Which of the following statements is true about a 0.1 molar solution of H2SO4? So when they say high Ka, what they mean by a high Ka is they mean complete dissociation. That's what they're saying. They're saying assume complete dissociation. So what's going to happen is I will have H2SO4, and that will completely dissociate into H plus and HSO4 minus. And what I will have is, because this is a 0.1 molar initially, I will now have 0.1 moles of H plus and 0.1 moles of HSO4 minus. The HSO4 minus will now form an equilibrium with more H plus and SO4 minus 2. So now what's going to happen is as I look at the answer choices, notice that they're looking at concentrations. Okay, so now I want to look at relative concentrations. Here I get 0.1 moles of H plus, and here I'm going to get more H plus. So now I know concentration of H plus is going to be greater than 0.1 molar, because I got some here. I got 0.1 molar here, and I'm going to get a little bit more. This 0.1 molar H2SO4 got consumed. So I know the concentration of HSO4 minus will be less than 0.1 molar. Now, if I want to find out what is the concentration of HSO4 minus 2, I will have to use an ice table. Okay? And I will have to assume that there is actually none of this left because it all dissociated virtually. So what do I have here? What I'm going to do is I'm going to use process of elimination and look for what is wrong. Okay, so once again, common sense here as I look at protonation or from what's happening here. I know this is wrong. Okay, I know this is wrong. The most it can be is 0.1. I know this is wrong, which means what I'm left with has to be the right answer. Now, notice that when I'm looking for what is wrong, I don't bother looking at the rest of the question. So if an answer choice is partly wrong, then all of it is wrong. And that's one of the things that you can use in terms of process of elimination, in terms of multiple choice, to very quickly eliminate answers rather than evaluating the whole thing to see if it is see if it works or not. So I hope this one was useful. I hope this one was a review of equilibrium that that you saw as well, or multiple equilibria, as you may have seen in your class. So it is a difficult problem. It would be considered a difficult problem. But as you see, even process of elimination and some of the techniques for answering multiple choice will make even some of the hard questions seem a lot easier. Now, that doesn't mean that these techniques should be used exclusively for the hard problems. They are just as effective for the easy ones and can cut down your time even on the easy ones. Okay, because this is diprotic, right? So if this were to completely dissociate, I would have 0.2 moles of H plus. So the first deprotonation gives me 0.1 moles because Ka is really high. So this goes to completion. Notice that I have a one-way arrow here. And then this species here actually goes through some more deprotonation. So I know I have H plus here, and I know I have a little bit more H plus here. I can calculate how much, but I don't need to, how much there is here. So that's how I know that H plus from here and here has to be greater than 0.1. Okay, so that was an answer to Jenna's question, asking how do I know that H plus is more than 0.1? I hope that helped. Okay. Let's take a look at this one. This is one of those questions, when you're looking at redox questions are among the most feared in Gen Chem. But like anything else, they are, with the right understanding, you can actually tackle these as well with ease. So let's take a look at this one. It says, if the above device is operated at 2 amps for 16 minutes to plate zinc with copper, what mass of copper will be deposited on the zinc? And they give us Faraday's constant. So what's the reaction happening on the zinc? basically we have copper plus 2, Cu plus 2. It is depositing here and forming solid copper around the zinc. Okay, so this is solid copper that is forming. So the reaction that we are looking at is Cu plus 2 electrons, or the half reaction, to give us copper. This is stoichiometry. Stoichiometry is supposed to be easy. So if it's supposed to be easy, we should be able to do this. Let me write this further up so I give myself a little bit more room. So Cu plus 2 electrons to give me Cu. Okay, so what I want to do, the first thing I want to do is find out the number of moles of electrons. But to find the number of moles of electrons, I need to find out how much total charge has actually transferred. Now, an amp is coulombs per second. So my charge is equal to my amps times time, which in this case is 2 times 16. And because they give me 16 in minutes, I have to multiply it by 60 to give me seconds, which is 32 times 60. Okay, so the charge is actually 30 plus 2 times 60. 30 times 60 is 1800 plus 120, which is 1920 coulombs. Moles of electron is equal to the charge. Let me put the formula down. Over Faraday's constant, which is 1920 over 96500. Yuck, yuck, yuck for numbers. This is approximately 2,000 over 100,000, which is equal to 2 over 100. 2 over 100 is 0.02. Yeah. So moles of electron is equal to 0.02. Now, given the stoichiometric for every 2 moles of electrons, I get 1 mole of copper. I know moles of copper is equal to 0.01, which means mass of copper equals 0.01 times 64, which will give me an answer choice of 0.63. Realize that you don't have a calculator here, so you need to break down your calculations such that they are easy to work with. That's why I did the approximation, and that's why I did what I did. Now, granted, what they do in electrochem is they give you an equation that goes through all of these 3 steps at once. Either you understand that equation really well and can use it here, or what you do is you do it 1 step at a time, like this. It doesn't take that much longer to do 1 step at a time, but what is nice when you break it down into the 3 different steps, at least you understand each step. And now if there's something weird going on or what have you, that happens, let's say, between these steps or between these steps, you can see it a little bit more clearly here because you've broken it down than when you are looking at it in one big equation where you got to work with it. So the takeaway from here is that complicated numbers are complicated. Round them off so you can actually work with simpler numbers and come pretty darn close to your answer. I mean, look at the answer we got, right? 0.64, the actual answer is 0.63. That's really close. Okay, let's take a look at this one. Now, remember, this is a half-life problem. To do a half-life problem, the equation is log something or the other. Yeah, good luck doing logs without the calculator, right? So what I like to do here is, so let's take a look at the question. It says, how long does it take for a radioactive substance to decay to 10% of its original amount if its half-life is 7 days? I like to make a t-chart. The t-chart is time on one side, and the other side, in this case, I would put in percent. The other side could be, it could be grams if they give you grams. It could be percent the way I have it. It could be activity if they give you activity in millicuries or what have you. I always like to start with time zero because this way at least I know my initial conditions are right. So at time zero, I have 100%. At time 7 days, which is one half-life, I have 50% of the sample. At time 14 days, I have 25% of my sample. At time 21 days, I have 12.5% of my sample. And at time 28 days, I have 6.25%. Now you will notice that 10 actually falls in between these two. And what you will notice is that in my answer choice, I only have one answer that is actually in between these two. So whenever you have a half-life problem, this is a good technique to use. So one of the things I would recommend here is as you are going through the test, as you are going through your multiple choice review, you want to look for ways to simplify the work. Now, your teacher may have told you about this method. There are other ways of simplification that your teacher may not have told you about. There might be some cutesy math tricks that you come across that you will find useful. And then what you want to do is you want to practice those techniques. You want to practice them on other multiple choice and see how well you do. This way you internalize them and you internalize the techniques. And now they will be second nature when you're doing the test. So here's one, uranium-235 absorbs a neutron and the resulting fission produces barium and krypton, and what other product will be formed? They're asking me to write an equation here. So let's go ahead and write it. That's what they want. Let's go ahead and write it. So this is uranium-235. And if you look in the periodic table, uranium is 92 plus a neutron. So here's my neutron, 1, 0. And that's going to give me barium 143. Barium happens to be 56 plus krypton, which is 91. And that happens to be 36. And then I have a mystery element. Now, the way this works is this is a nuclear reaction. So we're writing a nuclear reaction. But realize just as we were balancing chemical reactions earlier, or you learned how to balance chemical reactions earlier, these nuclear reactions also have to be balanced, which means 92 plus 0 on the left side have to add up to 56 plus 36 plus whatever my mystery element is. 235 plus 1 on the left side have to add up to 143 plus 91 plus whatever this mass number is in my of my mystery element. Now, sometimes they don't tell you this in school. because they want you to go through a certain type of reasoning, but this actually works. So let's take a look at my number downstairs. So this is 92 here. What does 56 and 36 give me? Okay, 56 plus 36 gives me 92. So if that gives me 92, then I know my number here has to be 0. This is interesting. 0 means no protons or any charged particle for that matter. So wherever I see a proton here in my answer choice, I need to eliminate that. So there are protons here and here. So let me eliminate those answer choices. What is a deuterium? A deuterium is actually heavy hydrogen. Does it have a proton? Yes, it has a proton. So if it has a proton, now you know that the answer has to be C, 2 neutrons, because that's the only answer choice that doesn't have a proton. Pretty exciting, Sharam. Okay. Here's the next one. It says radon 228 can decay by emitting the following sequence of particles. So they go through alpha, 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 beta, alpha, beta, and the resulting substance is an isotope of which one of these? Okay. What most people will do is they will start with radon 228. They will go through an alpha decay. They'll take that product of that alpha decay, go through another alpha decay, and basically they will follow the sequence of decays. What you want to do is you want to look at this and say, okay, I have 1, 2, 3, 4 alphas. So this is 4 alpha decay, and you know alpha is 4, 2. And how many are beta? They are 1, 2 beta decays. So now you have 2 beta decays, and you know beta is 0, -1. So now you can actually complete the reaction. You know radon is here. It was radon 228. And actually the uh, uh, element for radon is actually 88, I believe. Yeah, let me just double check that. Yeah, it is 88. Now notice here I have 8 minus 2. So this is my mystery element. 8 minus 2 is 6, which means this one here has to be 82, because 82 plus 6 gives me 88. Okay, so element number 82 is what, chat room? And hopefully you said it was lead. Okay. So we've learned a couple of things. And what I want to do now is go over basically approaching a multiple choice question. We've gone over how to approach single questions and some techniques for going through single questions. But how do you approach an entire section of multiple choice questions? How do you approach 60 multiple choice questions? So what do? is you scan the question, and so this is the question, not what they give you, but just the question itself, and decide if it is a now or later question. If it is a now question, do it now in your booklet. If it is a later question, mark and move on. And this is, of course, assuming a multiple choice test, a paper and pencil test. Okay. This method will not work for the digital, because on the digital, you can only look at one question at a time. So let me just put that out there. This is a technique for the paper and pencil, which is given twice anyway. Okay. When a double page is done, what you want to do is you want to transfer your answers to a bubble sheet and take a 5-second break. It's this 5-second break that saves you from actually, uh, it saves you from making stupid errors. Sometimes when you look at your work, you will realize you've made some careless errors or things like that. The reason why you make those careless errors is because your brain is looking for a break and you haven't given it a break. This is one way to make sure that you give it a break. And if you've worked it into the process, then that's even better. You're not looking at the clock each time. When all the now questions are done, do the later questions and start with the easiest ones first. Okay, and when you have 5 minutes left, use first pass elimination, guess and go. And you notice how I was eliminating in 2 passes? I would eliminate some answer choices and then ask another question and then eliminate the next answer choice. You may not have time for that second pass elimination. So, just if you got 5 minutes left, eliminate what you can, and from what is remaining, just guess, because you don't have time to do the entire problem. You're better off using this method with 5 minutes left. And if you have 60 seconds left, pick a letter that you want, that you like, and that's the letter you will use. There's no penalty for guessing incorrectly. So if there isn't one, at least put something down so that you get a chance of getting it right, rather than leaving it blank completely. Now, to prepare for effectively, you want to know the instructions, you want to understand what content will be tested, the test conditions, um, uh, you want to adjust your strategy and review the content and plan to celebrate after the test. How can we help you at Princeton Review? Well, the way we can help you is our strength is really on how to take standardized tests. So we have tutors and instructors that are ready to help students with the new AP format. And of course, we have live streams like this one here. We have scheduled tutoring. There is on-demand tutoring, and we also have some cram courses. In addition to that, what we have is we have these books that actually do incorporate some of the techniques and that we've gone through today. They do have full-length tests to help you prepare and see how you would do on an actual test. Okay, so at this point, I will actually take any questions that you may have. And if not, hopefully I will see you tomorrow for the short answers.